Hi everyone. In this lecture, we are going to talk about a very simple problem, that is finding the power of a number. Okay, so let me just tell you what the problem statement is. We are given a number a, and we are also given a number n, and we want to compute a raised to the power n. For example, let's say a is 2 and n is 10, then 2 raised to the power 10 is equal to 1024. So let's see how we can write this. Okay, so a raised to the power n can be written as, if we talk about the recursive breakdown, it can be written as a multiplied by a raised to the power n minus 1. So this can become our sub problem, and once we know the answer for the sub problem, we multiply it with a and get a raised to the power n. So that is one way of breaking down this problem. So first, let's see this way, and in the next video I will teach you an optimized way of doing the same. Okay, so let's quickly code this up, and we will also verify how this power function is going to work and how much time and space it is going to take. So let's think about the base case. So what is the smallest possible value of n? So it could be 0. If n is 0, then a raised to the power 0 is going to be 1. We can simply return 1. Otherwise, I can return a multiplied by power of a raised to the power n minus 1. That's it, and we are done. So we will take input a and n, and we will compute a raised to the power n. So yes, we are going to do it. Let's build the code and let me show it to you. So maybe 3 and 5. So 3 raised to the power 5 is 243, and maybe 2 and 10, it is 1024. Working perfectly fine. So let's have a quick look how this is working. So basically, let's say you're doing 3 raised to the power 5. So you have main. From main, you make a call as to this power function. A is 3. So a is always 3. So you say it is 3 raised to the power 5. So it says, let me break it into 3 into 3 raised to the power 4. So it says, okay, here n is 5. Here we will compute 3 raised to the power 4. It will make a call on 3 raised to the power 3. Here it will make a call on 3 raised to the power 2. Here it will make a call on 3 raised to the power 1. And from here it will make a call on 3 raised to the power 0. So when this is 0, it is going to return 3 raised to the power 0, that is 1. So 1 multiplied by 3 is 3. So 3 comes here. 3 into 3, it is 9. So it becomes 3 into 9, 27. And 27 into 3 is 81. And 81 into 3 is 243. That's it. This is how we get this particular answer. So talking about how much time it will take, it has performed n number of steps. It is order of n. How much space it is going to take, it is also order of n. Okay, so I hope this is now clear to you, and in the next lecture I will teach you an optimized way in which you can reduce the time and the space complexity of this program. See you in the next lecture.